It's 8 p.m. and you're at the animal park looking at American brown bears, with Jupiter visible in the background. It's then you realize how funny it would be if it was inverted. Bears watching humans! Well, Kyle, you want to be observed, do you? Told you to be careful about that when we were in Amsterdam, and it's a good thing I always know where to find you before your thoughts go too far, like the one you were just having. What would change if we inverted the planets in the solar system? Maybe Pluto being closest to the sun would evolve life. Could Earth in the middle of the asteroid belt shield the other planets from death? Or perhaps Uranus and Neptune could merge? Why don't I grant your wish to swap places with the bears and actually show you what would happen if we changed the order of the solar system in 3 very specific ways that actually make sense based on real solar systems we've seen out there in the universe. Firstly, you and this American bear need to understand how solar systems came to exist. About 4.6 billion years ago, the sun first formed by clouds of dense hydrogen gas getting obliterated by gravity, to the point fusion began and formed a baby star. What remained after the star was formed flattened into what's called a protoplanetary disk orbiting this new sun. Close to it, temperatures were too high for ice or gas to survive. Only rock and metal could come together, forming small dense worlds. But before that and farther out where ice and rock had clumped together, those icy cores grew massive enough to pull in the remaining hydrogen and helium around the baby sun, and these became the gas giants. It's why the system has remained stable for billions of years, like my fully stable ability to reenact our adventures with rat versions of ourselves. Yeah, I keep it all locked in a storage unit, don't worry. So, what do we have to look for a solar system to be inverted? Well, when we look beyond our solar system, we see planets that didn't stay where they formed. While this did happen with the Great Migration of Jupiter and Saturn II, around other stars there are basically entire systems of planets that rearranged themselves early on and still survived. Well, as far as we know. Like how if you were looking at these bears in the wilderness, Kyle, you might have survived by yourself, as far as we know. American Bear knows. Anyway, let's start with the first way we can invert the planets and see just what would happen to the solar system and Earth itself. It's time to turn the solar system inside out. Jupiter, Saturn, Uranus, and Neptune are now in the inner solar system, and all within roughly 1.5 AUs of the Sun. Earth, along with the other rocky planets, has moved outward beyond 5 astronomical units, where Jupiter normally is, into regions normally occupied by the gas giants. Firstly, the dominant change is energy. The amount of radiation a planet receives from its star increases sharply with proximity, obviously, following what's called an inverse square law. This simply means that when a gas giant, in this case Jupiter, that once orbited far from the sun is placed closer in, its upper atmosphere heats really fast, and the closer you get, the faster that happens, exponentially. That heat causes the atmosphere to expand, increasing its height and lowering the planet's ability to actually keep its gases. So the hydrogen and helium from Jupiter begin to escape through this process. The planet appears swollen and unstable as it's losing its mass. The same would happen to Saturn. What's that, Kyle? It's impossible and not real? You're a fool! Even American Bear knows the truth from reading those textbooks for literally the past 90 seconds. This behavior has been directly observed in other solar systems. One of the first confirmed examples was 51 Pegasi b, a gas giant called a hot Jupiter orbiting extremely close to its star. It demonstrated that Jupiter-mass planets can exist in these inner regions, but in a fundamentally different way, at like 1000 degrees Celsius or more, hence the name for all planets like it, hot Jupiter. Many such planets show massive atmospheres and clear signs of that atmosphere escaping, just like we said would happen to Jupiter. These systems are energetic and extreme, but this isn't the only thing that will happen to the solar system, of course. As these gas giants are now close to the sun, their gravitational power changes. A planet's area where they can stably hold all their moons is called a Hill sphere, and this sucker shrinks closer to the sun. Moons that were once loyal servants become less loyal. Some are ejected, others collide, and icy moons lose surface material as ice converts directly into gas. Remember, Saturn has like almost 300, Jupiter's 95 or so. It'd be a complete show within you in the solar system. See, moons don't really adjust smoothly, they just kinda break. Much like how I broke down in my Walmart when I found out they were out of Tropicana orange juice with no pulp. I had to suffer through feeling the tiny pieces grate my teeth. My whole day was ruined. But Hugh Jackman walked by me and made me feel better. He actually autographed my... Anyway, at the same time as the gas giants start melting and the moons start dying, the rocky planets of Mercury, Venus, Earth, and Mars have different experiences. With greatly reduced solar energy, surface temperatures fall so low that water freezes completely. Carbon dioxide and nitrogen begin to collapse out of the atmosphere and onto the surface, freezing completely. And the atmosphere thins and eventually falls like bad breath onto Earth's face. Geological activity, volcanoes and earthquakes and stuff, that slows as heat loss increases, and the planet becomes a quiet, frozen, and airless wasteland. Amazingly, the same thing would happen to Venus. It would just take a lot longer, like even up to 100,000 years longer. Obviously, Mercury and Mars will be the same, just frozen versions of themselves. So an inside solar system is not forbidden by physics, but their defining feature is instability. They can exist for a while, but after, most likely pain, suffering, death, I fear. Don't interrupt. Oh, of course, American Bear, of course. Indeed, gravity would also be truly fucked, but not in the way you think. For that, let's look at the second scenario. A simple change, but swapping the solar system from most massive to the lightest will show these profound effects. That's right, Kyle. Profound. So, from the first scenario, naturally the gas giants won't change their position, but now the Earth will be where Jupiter normally is. Of course, we will assume Earth doesn't get smashed by some asteroids from the asteroid belt in front of it, but the main point of this small change is that the solar system doesn't orbit the Sun. It orbits the barycenter between the Sun and Jupiter, the two gravity gods. This is simply the balance point of gravity in the solar system. It's technically just inside the Sun, so the Sun kind of just wobbles and orbits around that point, but with Jupiter being this close to it, that barycenter weirdness begins, because it shifts. And instead of having planets with clean, predictable orbits around the Sun, as we know, orbits start becoming tug-of-wars between competing gravity wells, the gravity wells that each planet has. Remember, orbits aren't circles, they are ellipses, which means they can stretch and contract and do weird things like this. What? I like to stay limber, especially now that we're stuck in this enclosure, much like how anyone who subscribes to Gravipull has maximum flexibility for all they need in life. So when massive planets are this close together, their gravitational pulls overlap. They exchange energy every time they go around the Sun, and this creates what's called resonances, where planets repeatedly tug on each other's orbits. For example, Earth in this situation will be about 5.5 AU away from the Sun, right? Well, because Jupiter moved right next to the star, it'll tug on everything else. And the Earth's orbit around the Sun will have a resonance that causes the closest point in the orbit to get closer, and the farthest point in the orbit to get farther. That means massive swings in temperature will come from this. Obviously we'd be frozen, but for a while imagine it was livable in certain small portions of land. Sometimes you'd be like 11 AU away and everything would die, and then suddenly you'd be perhaps 4 AU away and some life would return. Not us though, and not you. Not anything recognizable, because it'd take like 12 years or more to orbit the Sun now, and the atmosphere would no longer really exist, so perhaps it'd just be some giant-ass fungus. What? No, I said giant-ass fungus, not giant-ass fungus. You're disgusting. Remind me to send those witches after you so you'll also be cursed. Then both of our houses will be super clean. Far out, right? Just like how the Earth would move farther and farther out for millennia until it would be orbiting out where Neptune normally would be, or even Pluto. And as these resonances stack for each of the gas giants, orbits will begin to stretch and tilt. Planets start passing closer to one another than they ever should, and once that starts, the solar system will not correct itself. This is how planets get scattered. Uranus would get to have a crazy sideways orbit, which is okay because, he's already sideways. The rocky planets would now be thrown outward into long-distance orbits, and potentially some would be ejected entirely, becoming rogue planets drifting through interstellar space. Probably Mercury. Yeah, definitely Mercury. Not that we miss it. In fact, scientists used to always accept that a Jupiter this close to the Sun would just end up tossing almost all the planets out. But we know the truth now. Yes, you are right, American Bear. We've seen systems like this. That's how we know solar systems are wild and wonderful inverted things. Come on, let's get out of this animal park and into my new space shuttle so we can experience this together. My alimony check finally came in the mail. Thank God for those incredible lawyers that filmed my wife and my ex-best friend so I could win in court. Wait, do you guys want to get Timmy? Yeah.
I'm so pumped.
This is the star WASP-47, a slightly older and more massive sun, where a huge gas giant orbits extremely close to its star. Yes, another hot Jupiter, just like our new inverted solar system. But it gets even weirder. Mercury is normally 0.39 AU from the sun, yes? This planet is 0.05, and there are 3 other planets, a massive super-Earth even closer, a massive hot Neptune, and then another Jupiter-sized gas giant out in the habitable zone. This WASP system proves that Jupiters which are super close to the sun don't always throw out the rest of the planets nearby, as you probably expected to happen. However, could there have been more planets around this sun-like star in the past, and this is the final stage of its existence? Well, considering the star is like 2 billion years older than the sun, this is most likely the case. And the same thing could happen with our inverted solar system too. Perhaps it would keep arranging itself until gravity found something it could tolerate. Much like how I tolerate Kyle. But don't worry about that right now, because it's time to go back to the solar system and move the planets around one more time. Also because I have a date I need to prepare for. What, is she hot? What's wrong with you? I'm changing my life insurance policy. Yeah, literally. Rip Goose is getting more violent. But you know what the opposite of hot is, besides Timmy? Yes, the third scenario where we ask what would happen if Jupiter was the last planet in the solar system. And you know what? Pluto can be involved this time. Yes, come on, let's put him closer to the sun. There you go, fella. And we'll mix up the rest of the system like we did with the WASP system, but with obviously double the planets. So, now closer to the sun is Pluto, then Neptune, then Earth, then Saturn, then Venus, then Uranus, then Mercury, then Mars, and way out at the edge of the solar system, sitting where Pluto used to be, freezing its hydrogen off, is Jupiter. Just absolutely banished. But he will have his revenge. Instantly, things start breaking in ways that are very different from the last 2 scenarios. Let's start with Pluto though, because obviously Pluto near the sun does not become some cute little tropical ice world with beaches and life and good vibes. Pluto is made of nitrogen ice, methane ice, carbon monoxide ice, and the moment you put it anywhere near the sun, all of that turns into a teal blue gas, almost instantly. Pluto will grow a thick bluish atmosphere, almost overnight, not because it's healthy, but because it's boiling. And because Pluto has tiny amounts of gravity, that atmosphere doesn't stick around too long, and the sun's solar wind strips it away, non-stop. So Pluto basically turns into a comet, which we have actually seen from other exoplanets. But another demotion. Imagine being demoted from planet status twice. That's like being a Gibbons, the only lesser ape. Every other ape is a great ape except a Gibbons. What? Is Kyle a lesser ape? I guess he just might be American Bear. You know, you're a sharp one. Hey, can I ride you? Okay, right behind Pluto, Neptune is now way closer to the sun than it ever evolved to be. It doesn't melt like Pluto, but it does heat up and its ice glass storms intensify, its atmosphere puffs out and it starts behaving like what we actually observe around other stars. Hot Neptunes. Big puffy planets sitting too close to their stars that lose their atmospheres like Pluto is, and having some of the most outrageous extreme conditions you could possibly imagine at the most outrageous temperatures. I mean, we still don't know much at all about their formation because the first one ever discovered was Gliese 436b in 2007. Fresh science, baby! Let's skip Earth quickly because first we have to look at Saturn. Now, being this much closer to the sun means one very obvious thing dies immediately. The rings. Saturn's rings are mostly ice from murdering a moon over 1 million years ago, and ice does not like being closer to the sun. The rings will darken, erode, collapse, or vanish entirely, leaving behind whatever rocky material can survive. So Saturn would just actually end up looking naked like it has done for really most of its life. And this would happen in any of the scenarios we've looked at. But this is where the massive shift comes in. Cold Jupiter. All the way out at the edge of the solar system, barely receiving any sunlight at around 50 AU away. Its year becomes absurdly long, hundreds of Earth years. But the important part isn't the cold, it's what Jupiter does from out there. Remember the Berry Center? Yeah, now that's moved way farther out and the sun will orbit that, as will everything else. Orbits will shift just like in each of the scenarios, but out at the edge of the solar system, Jupiter stops being an asteroid protector like it is now, maybe, and instead starts being a slingshot, probably. See, there is actually an example of a cold Jupiter, HR 8799b. About 5 times the mass of Jupiter, it is 68 AU away from its star, and we have actual footage. Yes, that's it. Right there. Incredible. Now, that system has a few other Jupiters to kinda balance it out. In the inverted solar system, we would not. And because the Kuiper Belt is backed with billions of pieces of rock and ice, Jupiter will now forever be a threat to life itself. It's revenge. And while everything we discussed will probably happen in all 3 scenarios, just at different levels of power, at least it's not 2 galaxies merging, right?